Good morning, students. So today I would like to discuss with you about gradients of a line. So the gradient is a measure of the steepness of a line. So let's assume point A is given by coordinates x1 and y1. And another point, let it be point B, x2, y2. So the distance, the shortest distance between 2 points is a line, so we could draw this line. And how do we calculate our gradient? So we take the differences here. So if we analyze this triangle that we get, what would be those lengths? So this length down below here, since this is x1 and this point, well, let's call it C. Coordinates would be, well, x is the same as this one and y is the same as A. So same height as A, same horizontal distance as B. So those would be the coordinates. So this distance here would be x2 minus x1. That's this length. Now we can do something similar to calculate the vertical distance. So the vertical distance here, y2 is the highest one minus the lowest one. So if we are to calculate our gradient, for those of you who have done this on ISL, you probably remember rise over run, right? What is rise? Well, delta y. What is run? Delta x. So change in y over change in x. And there you go. So your gradient would be y2 minus y1 over x2 minus x1. The larger this value, it means the larger the distance in y is compared to the distance in x, so it will be steeper. So the larger the gradient, the larger this m, the steeper your curve is going to be, the steeper your line is going to be. If this value is very, very small, then it's less steep. It's not rising that much compared to how much it's moving on the horizontal direction. So let's take a look at this example here. Determine the gradient of the line joining the points A41 and BA3. So first, let's just assume that this is our origin. So this is 0, 0. So our frame of reference would be here. Now let's position those points in our coordinate system. So where would point A be? Well, x coordinate is 4. So let's assume that each of those squares is 1 unit. So here would be 4. And the height is 1. So this is where point A would be. What about point B? The x coordinate is 8 and the y coordinate is 3. So this is where point B would be, and that would be our line. Now to calculate the gradient, we simply have to do m equals rise over run. So that's y2 minus y1 over x2 minus x1. Sometimes you might see this as yb minus ya, xb minus xa. It doesn't really matter as long as you're consistent with your notation. So what is the height of b? Well, height of b is 3 and height of a is 1 over x coordinate. So the horizontal distance of b is 8 and the horizontal distance of a is 4. Therefore 3 minus 1, that's 2, and 8 minus 4 is 4. So our gradient is a half. So since this is positive, it's going up. If this value was negative, then it would mean that our function is going down. So m larger than 0, it's going up. M less than 0, it's going down. Right? Or it's decreasing. It's increasing, it's decreasing. M equals to 0, then it will be a horizontal line. Notice that you can solve this problem in a much simpler way if you just observe that this height is 2 and this horizontal distance here is 4, so you divide 2 by 4, you get half straight away. So sometimes if it's very simple, for example like this problem here, you might just go straight for 2 over 4 just because it's kind of obvious. So if you can see that, you can go straight for 2 over 4. You don't have to show like what is too obvious. So here we have a couple more examples. Remember that you can always pause the video and try to solve it yourself and then check the results later. So what you should try and find here are 2 points that you can pick so you can try and calculate your gradient. The best strategy here is try and look for points which are really easy for you to notice. So for example, if I get this point, it's kind of odd. I don't know if it's exactly halfway through. So what you can do in such a circumstance is, for example, wow, this point seems to be very well defined. X seems to be 2 and Y seems to be 5. So perhaps I could pick that point. Now let's look for another point. Usually we try to make this triangle very large. Since it's a line, it doesn't matter much, but in sciences sometimes this is a bad line of best fit, so you try to get a large triangle to minimize your errors. So here, this point here seems to be well defined, so we could call this B. X is equal to 10 and Y is equal to 1. Now you should notice, however, that there are other options as well. For example, this point here seems to be quite well defined, right? A2. This point here also seems to be very well defined, this one as well. But we're going to use those ones which are further away from each other. However, if you recalculate later by using those points here in between, you should find the same result. So let's go for our gradient. So gradient is rise over run, so y2 minus y1 over x2 minus x1. So y2 is the height of B, which is 1. y1 is the height of A, which is 5. x2 is the horizontal distance of B, which is 10. And x1 is the horizontal distance of point A, which is 2. So here, what we have is 1 minus 5 is take away 4 over 10 minus 2, which is 8. So as we expect, this is going to be a negative gradient. 4 over 8, that would be a half, so this is negative a half, right? Or negative 0.5. So that means 2 things. First, every time we go forward by 2 units, we're going down by 1 unit, right? So we're moving 2 to the right, we're moving 1 on the y-axis, and this negative is what this tells us that this is going down, right? So if this was positive, just like we had before, it would mean every time I go forward by 2 units, I go up by 1 unit. If it's negative a half, every time I go forward 2 units, I will go down 1 unit. Or you could even look at this as I'm going backwards 2 units, I will go 1 up as well, because you can visualize this as 1 over negative 2 as well, which is the same number, right? So going 1 up if I go 2 backwards, 2 to the left. Alright, so let's take a look at this second example here. So we're looking for the gradient, and we have to pick 2 points. 2 points for us to calculate our gradient. So let's try and pick two very well defined points, really well defined. This one seems to be really good. Now this one also seems to be quite good, right? What do I mean by good? Well, I can clearly see that this point is 5, 1, or even if it's not, it seems to be really close. So I will not make too many mistakes. My uncertainty will not be that large. My rounding will not be that problematic. So let's do it. Gradient is delta y over delta x. So rise over run. y2 minus y1 over x2 minus x1. So what are our points here? So let's call this point A and let's call this point B, and I'll write the coordinates up here. So point A, x is 0 and y is negative 1. Point B, x is 5 and y is 1. So if we take the difference, y2 minus y1, what we're actually doing, look, 1 minus minus 1. Because coordinate y1 is already negative. So since we have y2 minus y1, it's going to be 1 minus minus 1. Alright, so over x2. x2 is 5 and x1 is 0. So yeah, I don't even have to write this. So 1 minus minus 1, that's 1 plus 1, 2 over 5. So that's 2 over 5. You could write this as a number, which would be 0.4. And what does that mean? Every time I go 5 units forward, so 5 units to the right, I will go 2 units up. And we can see that. Look, from point A to B, I have walked 5 units forward and I've displaced 2 units up. So that's exactly our gradient here. Since it's positive, it's going upwards. Since it's less than 1, it grows more, it goes more quickly in the x direction than in the y direction. If this value was, let's say, 2, 4, any number larger than 1, then that means that our curve is steeper and steeper, right? 2, 4 would be even steeper, half would be less steep, and then if you go through negative values, then you would have, this would be the same steepness. I know it's not here, but it should be. And then you get to negative results. So let's take a look at a few more examples now. Okay, so new problem here. Determine the gradient of the horizontal line that passes through point 1, 2. So we're talking about the horizontal line, which is this one here. Now, even if you forget what I've told you about when the gradient is 0, let's just try to calculate. Let's assume that you have forgotten. So how would you calculate the gradient? It would be delta y over delta x. Or simply y2 minus y1 over x2 minus x1. And the thing here is, what is the change in y when we're walking in a horizontal line? Well, y never changes. If I pick, let's say this point seems to be well defined. Actually, all points seems to be well defined. If I pick those 2 points, for example, I've displaced an x by 4 units. However, my y has not changed. So this here on top will be 0 for any value, for any 2 points that I pick. So what happens is, since this is always 0, this will be 0 divided by some number. So this will be 0 for any points that we pick. So the gradient of that line is 0. And again, a gradient of 0 is only possible, so if you have a gradient 0, it means that it's a horizontal line. And also, a horizontal line cannot have a gradient different than 0. Now, let's go for the second one. Show that the gradient of the vertical line, which is this one here now, that passes through point D, 1, 2 is undefined. So again, we can basically apply our formula for the gradient, which is delta y over delta x, or y2 minus y1 over x2 minus x1. Now in this case, y changes. If I get this point, let's say, right, that's 1 to the right and 0 units up, and if I get any other point, let's say this one, my axis is still the same and y has changed. So in this case, x2 minus x1 is what's 0. And here we have a problem, Houston, because when we divide things by 0, that's really problematic. We would need some calculus to analyze things similar to those, and that's going to take a while. But the whole point here is that's undefined. Anytime you're trying to divide things by 0 and you don't know how to move forward, right, there are some techniques that we learn in calculus to deal with those divisions by 0, some of them, but in this case it's undefined. So any horizontal line will have a gradient of 0, and any vertical line will have a undefined gradient. So let's go for another example here. A is -2, -11, and B is 0, -5. So if we look here, our heights are quite away from each other, so I don't think I'll draw them. Let's just calculate those values. Can you imagine if you have here a y of -100? You might not draw them, you might not graph them, or even if you graph, you might not graph them up to scale. So let's just go for the equation here. That's delta y over delta x. Now it's AB. That's important. So that means our first point is A, our second point is B. So when we do y2 minus y1 over x2 minus x1, y2 and x2 are the properties of B, are the coordinates of B, whereas y1 and x1 are coordinates of A. So this would be then y2 is -5 minus -11 over x2, which is 0, minus -2. All right, so -5 plus 11 over -2, that's 2. So our gradient, -5 plus 11, is going to be 6 over 2. Everything is positive here, so that's 3. So basically that gradient is positive, so it's going up, and well, yeah, it's more steep than the previous examples that I've shown you so far. So this is the last example I'm going to show you today, and let's read it together. So a funicular railway has several stations along its steep track. Station A, with coordinates 30 and 60, is 60 meters above station 0 at ground level. Station B has coordinates 230 and h. All coordinates are given in meters. The gradient of the railway is 0.6. Find the height of station B above the ground. So there's a lot of stuff written here, but we only need the formula for the gradient. Well, but to solve it, let's identify the unknowns that we have here. So m, which is our gradient, is given. We know that our gradient is 0.60. What else do we know? Well, we know coordinates of B, which is our second point, and we know coordinates of A. So the only thing that we don't know actually is this height. So let's put those in our formula. So 0.60 is y2, which is the height of B, minus height of A, over the horizontal displacement of B minus the horizontal displacement of A. So if we take this difference down here, that would be 200. So now we can manipulate this. We may multiply the other side here, and let's see. So h minus 60 would be 200 times 0.6. I've just multiplied those two here. So h is 120 plus 60. So the height is 180 meters, right? The units given. So usually, if this was a physics problem, I would just leave m. Meters doesn't hurt. So our conclusion here is that station B is 180 meters above the sea level.